Welcome back to another lesson. In this one, atomic models. Now, this is important because it links into subatomic particles, our bonding topic, the periodic table trends, and the general history of atoms. Now, to start off, we'll look at the modern day atom to understand our subatomic particles. And using this diagram, we can see that we have our protons and our neutrons, which are both found in the nucleus. Lastly, we have our electrons found on the electron shells around that nucleus. Each of these has its own charge, with protons being positive 1, as well as having a mass of 1. Our neutrons are neutral, so 0, and they also have a mass of 1. And lastly, our electrons are going to be negative 1, with a mass of 1 over 1836. And I would recommend memorizing this number. Right. Now, with the evolution of the atomic model, first came along Dalton with his solid sphere model. He stated that atoms of the same element are the same, which we can see in that diagram. All carbon atoms look identical. He also stated that different elements have different atoms. So all hydrogen atoms resemble one another, and so do each of the copper ones, again demonstrated in a diagram. And lastly, he stated that atoms cannot be split. After this, Thomson brought along his plum pudding model, where he discovered the electrons. And with this, he stated that because atoms are neutral, there must be a positive charge. So these electrons were suspended within this positive particle, creating an overall neutral atom. After which, Rutherford came up with the nuclear model, where he fired positive alpha particles at a gold foil. And he found out 3 things. Most alpha particles went straight through. This demonstrated that atoms are mostly empty space. He also found that some of them were slightly deflected, which must have suggested that there must be a positive nucleus, as like charges repel one another. And lastly, some of them were deflected straight back, which also suggested that there must be a solid mass. And using these 3 facts, he came up with the nuclear model, where we've got the solid nucleus, or the solid positive center, all that empty space, and then the electrons orbiting. Bohr's planetary model, where he took the previous idea where these electrons orbited, and he stated that electrons actually move around the nucleus in these fixed shells, which are also referred to as energy levels, or electron rings. Using what we've just covered, give this past paper question a go. Take the next 2 minutes to work through this. Here are the answers to those questions. Here's another question to give a go. Take the next 2 minutes to work through this, and if you need more time, just pause the video, otherwise just skip ahead. Here are the answers to those questions. The first model, figure 1, is the plum pudding, and then we've got the nuclear model. And in terms of a comparative question, you always want to compare one with the other, stating similarities and differences. In this case, both of them contain electrons, and both have an overall neutral charge because they're atoms. Figure 1, however, does not have a nucleus, whilst figure 2 has electron shells. And of course, there are a few more on the screen as well for you to self-mark. Let's summarize. So, we started off with Dalton's solid sphere model, then moving on to Thomson's plum pudding model with the discovery of the electrons. And after Rutherford's gold foil experiment, we had the nuclear model. And finally, Bohr's planetary model. Right, our next lesson is going to be on electronic configurations. I hope you found this one useful. And don't forget, like, comment, and subscribe. I'll see you in the next one.